Right. So under this lesson, we are going to learn about how a particular data is represented by the computer. Now, as you and me, like all of us can see, we have opened a particular PDF document. So it is kind of a data that we have stored in my computer, right? So I'm referring to these. So these are something readable or something that I can understand. I means the user who is using the computer, right? But this is not the way that the computer understand the data, right? They understand the data in a different manner, right? So we generally say the computer understand things or understand data in ones and zeros. එක බින්දු පාවිච්චි කරලා තමයි එයා දේවල් තේරුම් ගන්න කියලා, right? That means the machine, not us, right? We have the things in human readable form, right? And okay, this are so it is there in a form something that we can understand, right? So if you think about, or if you just look into this particular PDF, this is from English. So if you know English, we can understand it, right? But what happens when we input data into the computer? How computer understand this, right? There's a nice example in your book explaining like what happens when you press the key, the the key A on your keyboard, right? So once you press A on the keyboard, that the circuit underneath that button in the keyboard is sending that signal to the central processing unit, right? Or the system unit. Actually, sending the system unit means it is sent to the central processing unit, because he is the one who is processing the particular input, right? And when that signal arrives at the CPU understands, okay, this particular user has pressed the A. Now he is opened the Word document software. So he is trying to type. So I have to show the letter A on the screen, right? That is how the machine responds to a key press. But CPU will not see the character A. A akura එයාට පේන්නේ නැහැ. Instead of character A, the signal of the character A will be received at the CPU. So signal is received at the CPU in this ones and zeros form. So that is why we are telling the CPU can understand ones and zeros, right? But if we clarify this in a very real way, right? ඇත්තටම මොකද වෙන්නේ කියලා හිතුවොත්, it is not ones and zeros that the CPU can understand. It's the change of the electricity that the CPU is going to understand. Because at the end of the day, your CPU, the chip, is kind of a electrical thing, right? And if you think about the system unit, it's a huge electronic board that you have. On the top of it, you can find ICs, circuit lines, some hardwares, and all these things. These are machines. So machines can understand the electricity changes, right? We call them the voltage electricity changes, right? So if we literally talking about what a machine can understand, the best answer is machine can understand the change of voltage. But for our easiness, this change of voltage is referred by 0 and 1, right? So high voltages will be indicated by 1 and lower voltage is indicated by 0. So whenever a particular CPU needs to understand something, it will receive a signal with these high voltages and low voltages. They are going to receive a sequence of those. Voltage එක වැඩි වෙච්ච අඩු වෙච්ච series එකක් එයාට හම්බ වෙනවා. එතකොට වැඩි වෙන තැන් එයා clear කරගන්නවා 1 as 1, අඩු වෙන තැන් එයා clear කරගන්නවා 0 කියලා. right? ඇත්තටම අපි තමයි ඒක 1s and 0 කියලා match කරගන්නේ. right? CPU එක voltage wise manage කරගන්න. right? But we simply, for the easiness of ours, we say CPU can understand ones and zeros. People, are you clear with this picture? Is that clear to you? What's happened inside the computer? So that's a simple example what happens when we press a key inside it. Yes, people, is that clear? Please confirm. Right, okay. How about others? Send me a message, people. Send me a chat message. Okay, right, okay. All right, if you're not getting it, just let me know, right? I'll explain it again. Right, now when it comes to the computer, is it only ones and zeros that is dealing with the CPU? The answer is yes. Binadi, okay. Binadi, the last part means like how the ones and how the low voltage and high voltage thing happens. Is that what you ask, Indua? All right, okay. Binadi, since the computer receives the electricity when we press a particular key on the keyboard, what happens is keyboard is go and touch the electrical circuit beneath the keys. right? Keys වලට යටින් තියෙන්නේ circuit එක. ඒක අපි key එකක් press කරාම එතකොට තමයි යා circuit එකත් එක්ක connect වෙන්නේ. circuit එකත් එක්ක connect වෙනවා කියලා කියන්නේ එතනින් signal එකක් send වෙනවා. So the signal will generate some several high and low voltages. right? ඒක තමයි signal එක create කරගන්න විදිය. right? එතකොට high and low voltages ටික match කරගන්නවා high voltages කියන තැන් ones විදිහට, low voltages කියන තැන් zeros විදිහට. right? So that high and low voltage sequence will be received at the CPU. So CPU can feel or CPU can understand, okay, some high and low voltage sequences arrived at me. So according to that high and low voltages, it converts or it represents or it understands the high voltages as 1 and low voltages as zeros. එතකොට තමයි එයාට සිග්නල් එක හම්බෙන්නේ සමහරවිට මෙහෙම වෙන්න පුළුවන් high low low high low high low ඒ විදිහට. එතකොට high කියන එක 1, low low නම් 0 0, again high නම් 1, again low නම් 0. So likewise it understands what's the message is, right? So even we can understand what is indicate from 1 and 0 in there, right? 1 0 0 1 0. The main example okay, like 1 5 zeros and 1 is there. So if we think about the voltage, if we map the voltage into this signal, it's going to be high and 5 lows and another high. Are you getting that, Binadi? Right, great. So that is how it is taken as ones and zeros, right? Okay, so then once the CPU receives that signal, CPU can understand from where this signal has came and what's need to be done. So the signal is came from the keyboard. For the moment, the monitor displaying the word processing software, according to our example. So that means if we are pressing a key, that letter should be appeared on the screen. So CPU will direct the monitor and direct the graphic card to send the graphics that is regarding the letter A. Now this is happening in a නේද ඇහිපිය ගහන වෙලාවකින් තමයි මේක සිද්ධ වෙන්නේ, right? But this particular thing is happening inside the computer. So today in this lesson, we are going to learn about how these ones and zeros are being arranged to represent the particular data inside it. Now, if you think about your keyboard, all the characters that you can see on your keyboard has a unique ones and zeros sequence to represent who they are respectively, right? Okay. So before we go to the number system part, do we have anything to, no, we really don't have anything to write regarding this. It's just the story if you can understand it. So now I'm going to introduce what are the number systems that we can use or that the computer can use to understand a particular data, right? Now, when we need to describe about the number systems, we talk about 4 particular number systems regarding the computing. So decimal is the number system that we use always, like in for our day-to-day deals, right? So if we represent something in a number, it's a decimal number system, right? So like we say like 10, 20, 5 ice creams, 10 toffees kind of things. It's always the number represent a value of the decimal number system, right? And today we are going to learn, apart from decimal number system, there are 3 other types of number system which use for the computing. There are many other number systems in the world, but for the computing, we just get to know about this binary number system, which is the base of 2, and octal number system, which is the base of 8, and the hexadecimal number system, which is the base of 16, right? So before I move to the other number systems, let's talk about the decimal number system, the thing we know, right? So to talk about the decimal number system, I'll remind you something that you know. Yeah, people, now this is an abacus, right? It is something that we, Dihan, so far we have finished 3 lessons, Buddha, right? So this is the 4th lesson that we are doing. So we are finished with the first one, second one, and the 6th one, right? So this is the 4th one that we are doing, right? So in the abacus, if you are given a particular fillings, you know how to represent the number by considering these, the number of balls that you can see there, right? So if I ask what is the number of number that represented by this abacus, you will clearly say it is 231, right? And if I ask the place values of this particular abacus, you will say these are ones, these are tens, and these are hundreds, right? So if I ask you to represent these numbers, the ones, tens, and hundreds, as an exponential of tens, the high බලයක් විදිහට මම පෙන්නන්න කිව්වොත්, how we are going to represent? 1 can be represented as 10 to the power 0. 10 can be represented as 10 to the power 1. And 100 can be represented as 10 to the power 2. Right? Is that clear, everyone? Can I have the confirmation, please? Yeah, right, okay. So now we can analyze how this 231 formed. නේද? ඔයගලන්ට පොඩි කාලෙත් මේක කියලා දීලා තියෙනවා. ඒකට ඊට පස්සේ අතරමැද්දේ අපි කතා කරන්නේ නැහැනේ මේ වගේ. So we just forget that, right? We really don't bother about it. But how this 231 is calculated or like formed, it is like this. Very simple. So you have 200s and 3 10s and 1 1s, right? So once you add these things up, 230 and 1 will give you 231. And this is how the value of 231 formed, but we are not really thinking about this. If we are given abacus, we just say, okay, this represents this particular number, right? So likewise, now why we are given the place values in ones, tens, and hundreds, or like as 10 to the powers, it is because we are talking about the decimal number system, right? So the decimal number system is the number system that we use every day. So in case if we are referring to a binary number system, its base is equals to 2. Like decimal number system's base equals to 10, binary number system's base is equals to 2. So if we draw an abacus for a binary number system, these places will be 2 to the power zeros, 2 to the power ones, 2 to the power twos, 2 to the power threes, likewise. The reason, it is because we are talking about a binary number system, right? So the same reasons that we are having 10 to the powers over here, right? It is because we are talking about decimal number system, so we have 10 to the powers. If we are talking about binary number system, we should have 2 to the powers because the base of the binary number system is 2. If we are talking about octal number system, these bases should be described in 8 to the powers. If we are talking about the hexadecimal number system, these places should be described as 16 to the powers, right? Just remember that fact, right? I'm just telling you, right? We will be using those when we are doing some calculations. I'll remind you the things from that point as well, right? Just remember, just have this picture in your mind, right? So with this knowledge, we are going to move to get to know what are the 3 different number systems that we are going to deal with today, right? So your book is having a very nice table regarding the number system and the characteristics of those, right? So I'm going to draw this in the whiteboard in a little bit different manner for you to clarify things, how the things are happens, right? Now, when we consider the number system, it has a particular name. So I'm taking it as number system and a base. And I simply say here the characteristics. Right? So now we are going to learn about we are going to learn about 3 particular number systems nibly, because we know the decimal number system, right? So we need to learn about the binary number system, octal number system, decimal number system. We are not going to learn about that, but we are writing it because we need to have the comparison, right? And something called hexadecimal, right? So as we discuss decimal number system, we know it is based on tens, right? 10 to the powers. So likewise, binary number system based on 2, octal number system based on 8, and hexadecimal number system based on 16, right? Let's just think about the decimal number system. Now, if you imagine any particular value that we can say, Like it doesn't matter whether it is from billions or trillions or millions or whatever the things, right? So if someone asks us to write a particular value, we will be able to write that value without a hesitation. But when we are writing a particular value in decimal number system, we use only 10 different characters to represent that particular number, right? 10 different characters means you can repeat the characters. It doesn't matter. But if you like search for the different characters inside that value, maximum that you can find is 10 different characters, right? ඔගොල්ලෝ කොච්චර ලොකු සංඛ්‍යාවක් ගැන හිතුවා. දැන් හිතන්නකෝ නේද? Don't ask me to read this. I really don't know how to pronounce this. Right? Right? Let's say this is a value. And if I ask to like figure out how many different characters are there inside this value, so you can figure out, okay, 3 is there, 2 is there, 4 is there, 1 is there, 5 is there, 6 is there, 7 is there, and we got 1, we got 3, we got 7, we got 6, we didn't got 0, and 9 is there. So how many different characters? 1, 2, 3, 4, 5, 6, 7, 8, and 9. What is the missing character here? We haven't used the character 8. Right? ඉතින් මම මගේ number එක දික් කරොත් තව ටිකක් ලොකු වෙන්න. Right? Here we got the character 8 as well. Right? So likewise, you can write any bigger value, right? Just by having or repeating the characters which is not exceeding the number of different characters more than 10. Right? මේක බලුවොත් එකිනෙකට වෙනස් characters ඔයගලන්ට දකින්න හම්බෙන්නේ උඩරිම 10යි. Right? So what are these different characters that we can use? This is regarding the decimal number system. So the different characters that we can use over here is starting from 0. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the only different characters that we can see in the decimal number system. Right? So how many different characters are there? Yes, people? How many different characters are there? Yeah, there are 10. So look at the relationship between the base and the number of characters. The base is 10. Number of different characters are 10. It's a very nice relationship between base and the characteristics of a particular number system. So binary number system is going to have 2 characters, 2 different characters. Octal number system is going to have 8 different characters. Hexadecimal number system is going to have 16 different characters. That is the relationship. And look at the characters. How we can define the characters? All the characters are starting from a 0. All these different characters, right? And continues, look at the decimal number system. It continues up to 9. That means 1 less than the base. Right? Base එක 10 now. The characters will be continue until 9. So with that relationship, if the base is 2, until when this characters is going to continue? Yes, people? After 0, what should be there? There should be only 1. Shouldn't be more than that, neither. Then it will break the theory. If it is octal, then we are going to have how many? 1, 2, 3, 4, 5, 6, and 7. Yeah, we are not going to go further than that because it is the relationship. Starting from 0 goes until 1 less than 7. right? Now, if we think about the 16, what should be the final character? What should be the value of the final character? Yes, Inupama, is it? Yes, people? Hexadecimal leke antima character ka. Yes, Dilmi. It's going to be 15. 15. Yes, Inupama, yeah, your representation is correct. But if we take as a value, it's going to represent 15. Now, if I continue the characters 1, 2, 3, 4, 5, 6, 7, 8, 9, then if I write 10, they are going to be a problem. The problem is 10 is using or 10 is repeating some characters, which is 1 and 0, right? Which is already over here. So we can't do that when we are introducing the number of characters or number of different characters in a particular number system. So because of that, they use a capital A to represent 10 and capital B to represent 11, C for 12, D for 13, E for 14, and F for 15, right? Like we are writing capital letters just to indicate, but we can use either a capital or a symbol. But in the number system lesson, it's better you use the capitals, right? So why these characters are there? Because they are indicating 10, 11, 12, 13, 14, and 15, right? So this is the way the characters of a particular number system goes on, right? Okay, people, let's write this down in this particular manner, right? Adhihan, there can be Puta. What Dhihan is asking, is there any more number systems than the hexadecimal? Dhihan, in conceptually, we can have many different number systems, Puta, right? අපිට පුළුවන් characters represent කරන්න ඕන තරම් නේද? ඒක ඉංග්‍රීසි හොඩි අකුරු ටික ඉවරුනොත් A to Z වෙනකන් ගිහිලි ඉවරුනොත් then we can repeat like A, B, and AC kind of things. But for computing, we are just referring to these 4 particular number systems. Yeah, Gavidu, you are going to write this after you write the headings. So hold on. So it's better you write the main topic, data representation methods in the computer system. That's going to be our main topic, the 3rd unit, right? So please take it down, and I'll keep it for a moment for the people who don't have the books for the moment. And people, it's better you get ready with the soft copy, or you have to collect the book from the school as soon as possible, because this lesson onwards, I have to give some homework for you guys, like regarding the copying some notes. Otherwise, we will run out of time, right? So just try your best to collect a book, right? So the 3rd unit, the topic is data representation methods in the computer system. And then we are going to write a subtopic called number systems. So write this subtopic and write this last line, copy that last line, and I'll show you the table that I have drawn on my whiteboard for you to copy, right? Right. Are we done copying? All right. I'm changing the screen to the whiteboard. You can write this. Okay, Dihan, hold on. Yeah, people just give second to Dihan, right? He's still copying. Right, here we go. Copy it down, people, and give me a second, people. I'll be right back. Meanwhile, just finish it up. Yes. Are we done, people? Right. Okay. So can we move? Is there anyone still writing this?
Yes, sir.
Right. Okay. Hurry up. All right. Can we move? Is there anyone still writing? right, let's move. Okay, so now since we know the characters which belongs to a particular number system, I'm going to ask you a question. Now, if I write some value, let's say 101, and I'm asking you to which particular number system that this value belongs to. Now, how we are going to figure out to which number systems that this value belongs to? All we have to do is just see what are the different characteristics or like different characters inside this value and cross-check whether those characters are there in this characteristics list. If you can find all the characters in the value inside your number system characters, then you can say this particular value is belongs to that particular number system. Simple as that, right? All right. Yeah, tell me people, 101, which number system that this can be belongs to? Tedara says it's binary number system. Is it only binary? Now, Tedara, yes, what's the rationale that you say that this 101 belongs to the binary number system? What was the logic behind that? Yes. Okay. Dilini and Ranuja has given me some answers which are correct. Yes, Tedara, that's correct, because it is belongs to 1 and the 1 and 0 is there, right? So 1 and 0 is there. So 0 and 1 characters, we can find it in the binary number system. But is it only in the binary number system? No. We can find 0 and 1 in octal number system as well. We can find the 0 and 1 in decimal number system as well. And we can see the 0 and 1 inside the hexadecimal number system as well, right? In all the number system, in all 4 number systems contains 0 and 1. So that means this 101, the value can be belongs to the any of these number systems, right? So now this is going to be a little bit confusing if we are referring this value to something or to represent some value, like a number can be belongs to the different kinds of number systems, but when we are referring to it, we should say what is the exact number system that this value belongs to, right? So for that reason, when we are writing things in the number system lesson, we use the particular base to indicate which particular number system that this value belongs to, right? But in the examination, you may have the questions like I asked, right? Like you will be given a particular value without the base, and they may ask, okay, which kind of number systems, or like what are the number systems that this value belongs to? There will be a very nice MCQ regarding that. So you only need this logic. So when you are asked a particular number system, you are going to search what are the characteristics inside the value, and you match those with the characters that belongs to that particular number system. So if all are there, you can say without a doubt, this belongs to this particular number system, right? And Dilini, Dilni, did you got what you have went wrong to? Right? So now you realize how it happens. Yes, very good, very good. Raninma, and you can realize it belongs to the other 2 number systems as well, right? Ranima, right? Yes. Right, great. Okay, so now let's move forward, right? So remember, you can be given that kind of questions, right? We'll do some when we are doing the questions. And if we continue, so now it's going to explain you the use of binary numbers in computer data representation. We talked about this, neither how a particular character A is going to represent or going to understand by the CPU, which is from ones and zeros. Like actually ones and zero means the ups and downs of the voltages, right? So then CPU understands what the data is, right? So I'm not going to talk about it again, right? So here in the node, they are trying to match these 1 and 0 positions uh, to a on and off states of the switch of a switch, right? So like we talk about, like the voltage has two different states, like high voltage and a low voltage. Here they are trying to map it to a on switch and an off switch. So on switch may indicate 1, off switch may indicate 0, right? So likewise, we can match it to several different scenarios, the things that we can see in the environment. So ultimately, what you have to understand is computer is taking the data, or like the CPU is understanding the data from ones and zeros, right? So I'm not going to do any explanation regarding this again, right? So we'll jump to there is a nice concept called the most significant digit and least significant digit. And before that, people, now this image on your book, right? Can you see there are some values given here and there? This is regarding the graphic editing software, right? So this is one of the place that we can see this computer is using different kinds of number systems to represent a color, right? Now, if you concentrate on this RGB values, which is inside this red circle, the first three values, it says 135, 31, and 120. Now, it is a decimal number, right? But the decimal representation is done due to a binary number, due to a binary value. So uh, we are going to discuss how a binary value is going to represent in decimal. So for the moment, 135, the value represents this particular binary number. And 31 is represented by this particular binary number. And 120 is representing this particular binary number, right? So now if we are going to represent a binary value over here, it will be harder for us, right? Then api grade 11 වලදී you are going to learn about the graphic editing software called GIMP, right? Now if I show you how GIMP is, I'm showing the GIMP because I can show you this particular window over here, right? So GIMP will start. Yeah. So in that, I can show you the color palette, right? Where you can find different kinds of colors on the GIMP software, right? So if I double click on this, I can see the color palette, right? So as you can see, can you see the values over here? R is 100, G is 100, B is 100, right? Something like that. So if I change the colors, if I click on here and there, you can see these numbers are changing, right? So it is because a particular color has a particular code. So when you represent a color inside the computer, it has a particular sequence of ones and zeros, and that ones and zeros is made out of these three colors, red, green, and blue. එක හරියට අපි bucket එකකට නේද දැන් ආට් කරන අය දන්නවා color එකක් හදාගන්න ගියාම you can mix the basic colors and make the other colors, right? So likewise, this computer is also referring to that method. They are mixing red, green, and blue in some different amounts to create the color that we are choosing, right? And that representation is given in decimal for our easiness, user ge ලේසියට තමයි decimal වලින් දෙන්නේ, but actually they are representing a binary value over here, right? Luckily, yeah, this is a free and open source software, right? And it has many different capabilities. I do all my graphic works using this, right? So yeah, Dihan asked me the question at the end of the class, but I'll answer it since it is out of the today's lesson, right? Yeah, this software is named GIMP, GNU Image Manipulation Program. Api GIMP කියලා කියන්නේ GIMP, GIMP, right? If you refer to the grade 11 book, the soft copy, you can find the particular software with that, right? So, and people, I want you to take your attention to this particular box. I then highlight kare in the ash color. So see, it has some BE6868 something, right? When I move my mouse pointer to there, it says hexadecimal color. Can you are you familiar with hexadecimals? Yes, we are familiar with hexadecimals. We just got familiar with hexadecimals, right? So hexadecimal color notation. So now we can understand the one we are going to learn is not just learning the number system. We are just learning about how the things represent inside the computer, right? So we can use decimals, we can use binaries, we can use octals. Sometimes octals are like using very rarely, but majorly binary and hexadecimal decimal is widely used, right? So this is one particular place where you can see the examples where the number systems are being used, right? Okay, so with that example, I'm going to jump to get to know about some basic components regarding a number system, right? Now here, for any number system, you got these components which we call unit, number, and base. Now unit means a single object, right? For an example, like amba godaking amba gediyak kiyala kiyanne, it's a unit, right? So from a bunch of money, like from a bag of money, one particular rupee indicates a unit. From a month, one particular day indicates a unit. So likewise, there will be unit for the number systems as well, right? And when we arrange the unit in a certain manner for a certain way, we can find numbers, right? So it is used to represent a particular quantity. Yeah, Ranuja, Puta, when we are representing, it doesn't matter whether it goes from the capital or simple, but for in your syllabus, it's better you represent it in capital letters, right? Dammata වැරද්දක් නැහැ, simple, but it's better you goes with the capital. People just excuse me, I'm getting a call from the school. Right. Dihan, GIMP is there to edit the photos. So I think you heard the software called Photoshop. Same can be done, or like more can be done from the GIMP, right? It has different capabilities, right? We are going to learn about that in grade 11, not here, right? Okay, so yeah, we are going to write these people. Yes, we have to write about this unit, number, and the base, right? So base, we know what the base is, right? Every number system is having a base, and base is indicating to which number system that a particular number belongs to, as well as base has some other relationship as well. We learned that number of different characteristics are equals to the base, right? So we can have that kind of a relationships as well. So anyway, we are going to write these things. So what you are going to do is don't put any subheadings, right? So these unit, number, and base and radix, let those be subheadings of yours. So copy it from here to here, right? Do it as quickly as you
So we have
can.
below the table.
Yeah, below the table. Yes, Buddha. You don't need to go for any subheading. Just below the table, just write these things. Yeah, lucky though, I'll send it. I'll send it. Oh, yes, Dihan. That is what you need to do. Yes, yes. Let me know when you are done. Okay, two are done. Is there anyone still writing this? All right, can we move? Please indicate if there is anyone still writing this. All right, so we are going to move. Right, now, yeah, these are some stuff that we talk about, people, so I'm not going to explain it again and again. They are just explain the things in a very descriptive manner, so you know about these things. Now I'm going to take your attention to a very nice concept called the least significant digit and the most significant digit, right? So the most and least significant digits, or the values, we can say, right? So this is something that you need to understand, because we referring to these positions when we are going to do some calculations, right? So for every number, there is a place where we can address as the most significant value and as well as the least significant value, right? So how we are going to recognize this? So it's easy, but you have to remember the logic that we are going to do, right? So the logic is this. Now, when it comes to a number, when it comes to any number, there is a place always which indicates the least value, aduma age thiyena place එක, and the most value, වැඩිම age thiyena place එක, right? And if you think about this this particular abacus, if I draw something like this, right, and you know the like, let's assume this is from the decimal number system, and you know this is from 10 to the power zeros, this is from 10 to the power of ones, and this is from 10 to the power twos, right? That means 1, 10, and the 100. Now we know the value which represents here is 113, and from these three values, which holds the biggest value inside it, from these three characters, which holds the biggest value, I'll for your reference, I'll make this 2. I'm sorry. Now the number is 123. I need to know who holds the biggest value. Is it 1, or is it 2, or is it 3? If you think it from the position values, then you can realize. Place values එක compare කරොත්, these are the place values. Which character holds the biggest value? Yes, Tedara, that's correct. Here, 1 contains the biggest value because 1 indicates, yeah, 100. And who contains the lowest value, or the lowest weight? Who has the lowest weight? It's 3, yeah, because it says it's 3 in 1, right? So this is a particular place which represent the most significant value, which is the 1, and the least significant value, which is the 3, right? But this differs when it comes to the decimal values. Decimal means like decimal නෙමෙයි, අපි ඒකට කියන්නේ floating point values, right? Like දශම සංඛ්‍යා කියලා අපි කියන්නේ decimal numbers කියන එක නෙවෙයි. I'm indicating the floating point value, දශම සහිත සංඛ්‍යා, right? So when it comes to the floating point values, this is going to be a little bit different, right? So we have to have that logic to recognize who has the most significant value and who has the least significant value. So for that purpose, we are going to talk about how we are going to recognize these, right? So first, I am going to talk about the most, let's talk about the least significant value, right? So the topic, just a second, people. Yeah, let's talk it from the digit part, right? So the first one we are going to talk about is least significant digit. We call it in short form LSD, right? Now, I'm going to talk about this for two different values, which are for the integers or the whole numbers. It's a different way of identifying it. And when it comes to the floating point numbers, there is a slight difference to recognize this particular thing, right? Yeah, thank you, Rusila. Right? So people, so regarding an integer, right? Regarding an integer, LSD is recognized as rightmost character, right? So that's the theory. Regarding an integer, we are talking about whole numbers, right? Which does not have any decimal part or fractional part. Regarding an integer, LSD is recognized as the rightmost character. So what are the examples? These are the examples. Let's write. So I'm going to write the number over here and LSD at the other side. So if we think about a value like 25, the LSD is going to be 5. If we think about something like 250, the LSD going to be 0, the rightmost value, right? And if we think about a one particular digit, like 3, it's going to be 3. LSD is going to be 3 because there is only one particular digit, right? So likewise, for a whole number, for an integer, we consider LSD as the rightmost value. Yes, we have to write this, right? So people have the heading least significant digit. So you can write this, right? And Dihan, පුතා අපි මේ කතා කරන්නේ වැලිව් එකක තියෙන يعني අගයක තියෙන අගයෙන් අඩුම කැරක්ටර් එක ගැන. right? ඒක තමයි අපි least significant digit කියලා කතා කරන්නේ. right? එතකොට ඒක හඳුනා ගන්න විදිය තමයි අපි අරගන්නේ. කියන්නේ right most value එක කියලා කියන්නේ දකුණු අත පැත්තේ කෙළවරේම ඉන්න කෙනා තමයි අපි පූර්ණ සංඛ්‍යාවක integer එකක LSD එක කියලා recognize කරගන්න. right? Okay. Clear the? Right, great. Okay, write it down, people. Meanwhile, I'm going to write the fractional part as well. So you can continue, I'll explain it to you, right?
So we have to write this?
Yes, you have to. Start it from the least significant digit, right? Right, let me know when you are done. All right, one is done. So let me move this little bit upwards, right? So I can write the example regarding the least significant digit. Right, so the examples are going to be, yeah. Before I write the example, people just hear me out. I'll give you time to fill this up, right? Now, when it comes to the floating point values, floating point value means like decimal values, right? If we consider something like this, 2.57, 2.57. Now, regarding a floating point value, what did I say? LSD is recognized as rightmost value, which is not a zero, right? So you are going to look for the rightmost value. But it shouldn't be a zero. බින්දුව වුණොත් දකුණත පැත්තේ කෙළවරෙම ඉන්න කෙනා එයාව disregard කරලා ඊළඟ එක්කෙනා ඊට කලින් එක්කෙනා ගැන තමයි අපි බලන්නේ. Right? So the rightmost value which is not a zero. So in here we don't have any zeros at the very right. It's 7, so LSD is going to be 7. If we take something like this, 30.20, if the value is given like this, LSD is going to be 2, right? Not the 0, right? If your value is something like this, 0.030, again, LSD is going to be 3, not the rightmost 0. People, are you clear with this? Let me have the confirmation. Right, okay. So copy it down. Let me know when you are done, right? Okay, Trusira is very fast. He's done already. Okay, 2 are done, 3 are done. That's nice, people. So is there anyone still writing this? Okay. All right. So it seems everyone is done. So I'm going to move to the most significant digit, the other one, right? So most significant digit, how we are going to recognize the most significant digit? Now, least significant digit, that is there at the rightmost corner, and most significant digit is going to be at the leftmost corner. But when you are considering the leftmost value or the character, remember to omit the leftmost zeros because they are not going to consider as the most significant digits. අරගන්නේ MSD කියලා, most significant digit එක කියලා. But if you find a zero as the leftmost one, disregard that, go for the previous one or the one before the zero, right? So leftmost character of a value will be recognized as the most significant digit, right? All right, so let's write it down. Most significant digit. So in simple terms, we say MSD, right? So MSD is going to describe as leftmost value. I'm sorry, leftmost character, let's say. Yes, Ranuja. In 250, we consider 0 as the as the LSD. Yes. So the examples, here you go. The number and the MSD, most significant digit. So if we take 250, the most significant digit will be 2. If we take 30.20, most significant digit is going to be 3. If we are going to take 07 as the number, the most significant digit is going to be 7, the leftmost value, which is not a 0, right? And if you take, let's say 6, just 6, MSD is going to be 6. And this is something special. If you think about 0.0325, the most significant digit is going to be 3, leftmost value, which is not a 0, right? So in its left, you can find a 0 over here. So we are going to disregard it. And then again, we are finding a 0 and we are going to disregard that as well. Then we find 3. So that is why 3 is going to be most significant digit. People, is this clear to you? Okay. So copy it down, people. Then we can end the session. Right. So by next week, we are going to discuss how the conversion happens in between the number systems, right? So we are going to convert the decimal values into the binaries, decimal values into the octals, decimal values into the hexadecimals, like, which is pretty easy and pretty kicking as well, right? So get ready for that, as right. We are going to do some calculations by next week. So thank you very much for today. I'm going to end the session from here. And people who got questions with you, you can stay. Others, you can leave. Have a good night, people, right? And stay safe. We are going to meet tomorrow on 5:45, right? Today we got a little late because I was starting the single session a little late, right? Thank you very much, everyone. Have a good night. All right. Okay. I think I got some questions. People, please post me the questions again. I can't. It is going high away in the chat, right? So yeah. Good night for everyone who is leaving. And question, people, you can ask the question. Risara, I like the homework. Are you like referring to the homework that I have given last week, Pudha? Risara?
Sir,
Yes, Risara, ගිය සතියේ දීපු homework එක ගැනද ඇහුවේ?
නෑ සර් මේ පාඩමේ හෝම්වර්ක් දුන්නාම සර් කලින් කිව්ව හෝම්වර්ක් දෙනවා කියලා එතකොට පෙන්නන්නේ කොහොමද ඒක?
මේකේ පුතේ මම homework දුන්නම ඔයගලන්ට WhatsApp ෆොටෝ එකක් ගහලා WhatsApp කරන්න තමයි තියෙන්නේ.
Okay sir.
Right, okay. Dihan, how to add single keyboard? Okay. Single keyboard means like you want Single on your computer. Is that what you want, right?